So completing the square, what this is so we're doing more factoring. Woo-hoo! So our factoring problems, I always have given you nice ones that actually factor, and if they didn't factor and asked you to factor, you'd say franc. Or if it was solving, where there's an equation, an equal sign, and you couldn't factor it, what would we use instead? Okay, quadratic formula. Well, another way that you can solve without using quadratic formula, without factoring, is called completing the square. In fact, the quadratic formula is derived from using the completing the square. So what this does is basically we start off with the polynomial that's not factorable as is, and the idea is that we take our constant, move it to the other side, and then we add and subtract in a value that makes this into something we can factor. Once we factor it, then we're able to use square roots to solve, and we get our solutions from there. So that's what we're going to be doing for the first part. What this does for us with ellipses is that when our equations are in a not so nice form for ellipses, such as, flip your paper over, this guy. What is our center? What is our vertex? What is A? What is B? I don't know. This is in standard form, not vertex form. And so we're going to convert it into the form that we like, so we can easily pull this information from here. We're going to do it. So that's where we're heading with this. This is why it's important just for our ellipses. You'll do much more of this in Algebra 2, so you're welcome that I'm refreshing your memory on completing the square before next year. Okay. So our first step, right now we're just going to take a look at it in terms of solving the equation. Not looking at ellipses, just how to solve the equation using completing the square. So the first one says put the equation into the form where we add or subtract our constant over it. So for this first one, I want to add my 20 over, so I have x squared minus 8x equals 20. Now, right now, obviously we're doing it step by step by step by step. We probably combine some of these steps. When I go through and do it on my own, I would honestly just go leave a big gap there because we're going to write something in it. But for right now, we're just going to follow step by step. All right, part 2 says to divide all parts by A. Once we get to our ellipses, instead of dividing, we're just going to factor down. Here, my A value is 1. We don't have to worry about that. As you can see, for example 2, we would have to do something with that. We'll get there. Okay, so we still have x squared minus 8x equals 20. Okay, so step 3, this is part of our work off to the side. So we're not manipulating this equation just yet. We're going to do a little bit of work off to the side, and that information we're going to take and put back in. So that's why this box is going to be grayed out, so you know it's a separate step off to the side. So it says take half of b and square it. So just a reminder, we have ax squared plus bx plus c equals 0. We added our c over, so our b value is just a coefficient that's with x. So it says take half of b and square it. So b over 2 quantity squared. What is my b value in this? Negative 8. So we get negative 4 squared, which would be 16. I'm going to write it that step. Let me write it smaller so it's easy. I have negative 8 divided by 2 quantity squared, which is negative 4 quantity squared, which is 16. Okay, this is a really important piece of information for us. Alright, so step 4 says to take that number that we just found from step 3 and add it to both sides of the equation. So I have x squared minus 8x. And I'm going to go and write my 20. So we want to take our 16 and add it to both sides of the equation. Plus 16 plus 16. Why am I allowed to take a 16 out of thin air and throw it down there like I have?
Because they'll still be equal.
They'll still be equal. Good. So when we do this for ellipses, we're going to be completing the square within one side. So instead of adding it to both sides, we'll actually add 16 and subtract 16 on the same side. So what I mean by that is we would do x squared minus 8x plus 16 minus 16 equals whatever number we're talking about. Why am I allowed to do this? I'm only affecting one side of the equation. Why is that still okay? Yeah, They cancel out, they're 0. So I still have to change the value of the equation. Okay. So again, our goal is to be able to factor the left side. I probably should have had us check in the very beginning if we could have factored it. So let's ask now, can we factor x squared minus 8x minus 20? Are you sure? Negative 10 and 2? Oh wait, we could have. That's okay. I'm using the easy problem to show you how to do this, and then we'll look at the hard one. If you can factor it, factor it. But completing the square is a method to use when you cannot factor it. Okay, so now let's factor the left side. What does x squared minus 8x plus 16 factor into? Take a minute, think about it. What does this factor into? We need what multiplies to 16 that adds to negative 8. Negative 4, do we agree with that? So x minus 4, x minus 4. Okay, so this side factor to that. 20 plus 16, 36. How can I rewrite this instead of x minus 4, x minus 4? Good, so I can rewrite this as x minus 4 quantity squared equals 36. What's really cool with this is when we complete the square, whatever we did up here after we've added in that b over 2 quantity squared value, then this will always factor into x is it minus b over 2 plus b over 2 minus b over 2 minus b over 2? Yes. No. Plus. Minus. Plus. Minus. Plus. Plus. Give me a moment to have a conversation with myself. Plus. X plus b over 2. So, if you remember this, awesome. You can just do that shortcut, or you can factor it. What this is our b over 2 value. If we look up here, our b over 2 value, so it's our value before we squared it, and then just negative 4. Oh, x minus 4 squared. So, if you remember this, this is always going to factor into whatever this guy was, x plus that quantity squared. Or if you don't remember that, you can just factor like that. Now, something I've told students in times past to help them remember this is that notice this is our b over 2 quantity squared. Really, all that happened from there to here was just the x plus that. See how it's this quantity squared? You just really threw an x in front. If that helps you out, great. If not, so that's fine. Okay. So now we can go and just solve this using square root, something you did back in algebra 1. This is a quantity squared. It's the only thing on this side of the equation. How do we get rid of a square? Square root. So I'm going to square root both sides. So we get x minus 4 equals, good, work with the plus or minus vector. X minus 4 equals plus or minus 6. And then we just solve for x. So that's just x equals plus or minus 10, right? No. What do we have to do?
They have to add it.
So it's, when we add it over, it's x equals 4 plus or minus 6. What's 4 plus 6? What's 4 minus 6? Negative 2, not negative 10. So be careful, that's a common mistake people make, is they just add the 4 and add that together with it. But it's really a positive 6 and a negative 6. So it's 4 plus 6 and 4 minus 6. Okay. Now this one, because it gave us nice whole numbers, that's going to tell us that k was actually factored. Again, if you can factor, awesome. Do so. You don't need to complete the square. Completing the square is a tool that we can use when we can't factor. Obviously, you can use it when we can factor as well, but it's faster just to factor. Okay. Questions with the general process before we do example 2, where we actually have that coefficient in front. Okay. All right, so again, the first thing is to go ahead and move our constant over. So if I subtract my 25, I get 3x squared plus 18x. What's 70 minus 25? Okay. I don't want this 3, so I'm going to divide both sides by 3. And I have to divide everything on that side by 3. So we get x squared. 18 divided by 3? 6x. 45 divided by 3? 15. All right, time to find our b over 2 quantity squared value. B is 6 divided by 2 quantity squared, which is, so this is what we are going to add to both sides of the
6 and not 18. I mean, not 16, not 18.
equation.
18 isn't 8.
We want it from after we've divided both sides. Yeah. So when you're completing the square, we always want our coefficient to be 1 before we actually start to morph our polynomial there. Other questions so far? Okay. So this is what we're adding to both sides. So I have x squared plus 6x plus 9 equals 15 plus 9. Alright, we can factor this guy. Assuming we did this correctly, we should just be able to take our value here and stick an x in front of x plus 3 quantity squared. Do a quick double check. If we multiply this back out, does it give us x squared plus 6x plus 9? Did we do it right? Yeah, good. What's 15 plus 9? 26, right? 24. You'd be surprised how many of you guys would say 26. And no, it's a subtraction you guys usually mess up. What is 15 minus 9? Is it 6 or is it 4? 15 minus 9?
Oh,
Okay. Alright, so now we go ahead and square root both sides. So x plus 3 equals, I bet we could break this down. 4, 6, 2, 3. So we get plus or minus 2 root 6. Then we solve for x. When I subtract my 3 over, can I combine it with the 2 root 6?
Yeah.
No. So we can go just write it negative 3 plus or minus 2 root 6. You can write it separately if you really desire. I like to just leave it like this. If you were to do quadratic formula, you get that same exact answer. Sometimes completing the square is more desirable than quadratic formula because the numbers can get a little big underneath your radical in quadratic formula, but they both will yield the same result. Questions with that? Okay. So I want you guys to go ahead and try with examples 3. It specifically says to solve by using complete the square, so I want you to complete the square. Even if it is factorable, although I don't think this one's already. Not when it stands for velocity. Feel free to glean from those around you. Feel free to ask me questions. Give this place a throw. Because you'll do it again in so algebra 2 and pre-calc, and then in calculus again, but with integration. Now it's
That was so random.
They were looking at me.
Yes. Go ahead and do both 3 and 4.
Wait. Wow.
Are we getting both original?
Yes, both.
So it's just your first podium. So it's one So here. Well, I used to do that. I never be to. I'm looking at my side front.
Then we'll give an example of that.
To know what it is.
Did we? Oh, yeah. I just remember the quadrant. That's all I remember. Was it slightly down?
No, like,
I think this is, was this one your class? Yes, it can.
yeah.
Now.
Are you serious?
Oh, yeah, I get it.
I got to do it right.
It started. I was telling you everything. Come on.
You're going.
The names.
No. I didn't know for
Oh,
You only asked an equation. That's right. Why are you
We got 15 points.
Yes. Okay, so we're taking whatever the value is when the first one, like just the B or the X. So we have 6. So off this I'm going to do 6 divided by 2, quantity squared. So do like parentheses, 6 divided by 2, parentheses squared. Just write that off the side. Okay, and then we're just simplify. What is 6 divided by 2? 3. Good. What is 3 squared? Good. So that's how we know we're going to add 9 to both sides. No, so now this is something we can factor. So now this will factor into the whatever it was before you squared it. So B plus 3 squared. Alright, do we agree with this guy on the right? Okay. What did we get for our answer for 3? Negative 3 plus or minus 2 root 17? Does anyone have questions on that? Okay. For both examples 3 and 4, well, for example 4 here, I went ahead and showed you the formatting that I use for it personally when I do these. I like to do my b over 2 quantity squared off to the side, and then when I do my complete the square, before I find out what it is, I literally draw little lines underneath to remind myself, hey, whatever I get there, I'm going to add to both sides. So I do this off to the side, and I know I'm going to add 1 to both sides, and then I proceed with there. You do not have to follow the same format, it's just what I personally do when I do this work. Okay, do we have questions with this? Alright, so you'll see this note at the bottom. When we're doing with ellipses now, we're not actually solving for an answer in the end. Our goal is to get it into this nice, this guy here, where it's that product, or it's a binomial squared rather than this big long polynomial. Because if you think about our ellipses equation, it's x minus h quantity squared divided by some number. And then plus y minus k quantity squared divided by some number equals 1. So what our goal is to get it in this nice format, which we will use to complete the square for. So we're not actually solving for numbers in the end. We're not going to have like x equals y equals. So we're going to do it slightly different, but it's still the same idea of how we complete the square. It's just not completing the square to solve. We're just completing the square so it's a nice factorable thing. So let's take a look at how to do it. Backside. Okay. So the first thing is that we're going to complete the square twice. Complete it with the x's and complete it with the y's. Okay. So let's first go ahead and rearrange this. So I have my x's together. So I have x squared plus 6x. Do I want to go ahead and draw in my line here? I think I'm going to. Ooh, it's a constant question. So I'm going to go ahead and draw in that like blank line that I'm going to fill in with completing the square. All right, so that's my x's, and then let's go put our y's. So I have 4y squared. I guess we'll start off with this one. Okay, minus 8y, and I'm going to be adding something there. I still have my plus 9. I'm going to go ahead and subtract my 9. Get it out of my way so it doesn't clutter things up. So I basically just taken my x's, gathered them together, my y's, gathered them together, and went ahead and drew in my blanks that I know I'm going to use to complete the square. Okay, let's start with our x's over here. we don't have a leading coefficient of other than 1, so we can go ahead and do our b over 2 and add that. And I'm going to want to add it to both sides of my equation here. Okay, so my b over 2, if you need to write it off to the side, you're welcome to do so. If you can do it mentally, that's great. I'm going to write it off to the side here. So b over 2 quantity squared, which would give me 3 squared, which is, are we in agreement with that? Are we okay with that? Okay. So I'm adding 9 to this guy. I'm going to add it here. And I have to maintain my equation, so I'm going to go ahead and also add it. Okay. So I'm going to just continue with my x, just so we can kind of complete the thought we're completing this board before we dive into our y's. Our y's are a little more difficult. So let's go ahead and factor this. What will this factor into?
X plus 3 squared.
Good. X plus 3 squared. See how quickly we were able to get that to be something factored? Woohoo! Okay. Now our y's are a little more difficult here because we have that leading coefficient. Now before we just divided that on both sides. But here what we need to do is actually factor out that 4. Okay? So I'm going to go ahead and factor out that 4. So I have y squared minus 2y, and I'm still going to leave this blank in here. It's going to throw us for a little bit of a loop, but that's okay. So we want to factor out that 4 because we want our leading coefficient to be 1. Okay, so we've got to do our b over 2 quantity squared. Again, if you can do it mentally, awesome. If you need to write it down, that's perfectly fine. So do it off to the side here. So my b is negative 2 divided by 2 quantity squared. Be negative 1 quantity squared, which would be 1. Alright, are we okay with that? Questions so far? So I would be adding 1 to both sides. Now here's the tricky thing when we've got a coefficient in front. So I added 1 here to be able to complete my square, but I didn't actually add 1 to the left side of my equation. What did I add instead? 4. Why, Danny? Right, it's 1 times 4. So I added 1 within my parentheses here, but that actually is 1 times 4, so it's actually 4 that I've added on the left-hand side. So instead of adding 1 over here, what do I need to be adding? 4. Okay. Are you guys okay if I simplify this as 0? Negative 9 plus 9, 0? Yeah, okay. And so then I delete that screen. Okay, so then I'm adding 4 plus, or times 1, which is awesome. So now we can go ahead and complete our square there. So I've got my x plus 3 quantity squared. We're done with that. It was easy. What does this factor into? Good. Y minus 1 quantity squared. And then this is just 4. Sweet. We are so close to being able to have it in our normal format. So what is our final step that we need to do to get it into that beautiful ellipse format that we can easily graph? What is it? Yeah, deal with this 4 here. How do we deal with them? Divide them out. Good. So divide both sides by 4. And everything has to divide by 4. So now I've got this beautiful equation. X plus 3 quantity squared divided by 4. Oh, how convenient for my y's. The 4 is reduced. So y minus 1 quantity squared. If you need to, if it helps you out to write it over 1, that's fine. So it was a bit of work, but it really wasn't too bad to get this into a format that we recognize. Now we can so much more easily write our center, our vertices, our co-vertices, and our foci. By the way, I was pronouncing it wrong. It's not foci, it's foci. Not foci, not foci, foci. Okay, so now let's go and answer our little pieces of information here. What is our center? Negative 3, 1. Good. Now this would be an example where we have to do our vertices and our co-vertices without having graphing it. So, what's that? So let's go ahead and identify our A and B values. What is my A value? 2. I'm going to highlight my final equation here so it brings our attention to it. Okay. So my A value is 2, my B value is 1. My vertices, does that talk about my A value or my B value? A value. Okay, so vertices is talking about my A value. My A value is affecting the x's. So I just simply take my center, and for my x value, I'm going to add 2 and subtract 2. So -3 minus 2 would be -5. And then -3 plus 2 would be -1. Boom, we have a vertices. All right, co-vertices. You also have our B value. Our B value affects our y's. So with my center, I'm just going to affect my y's. So 1 minus 1 would be 0. And 1 plus 1 would be 2. Woo, we got our co-vertices. Yes, that's right.
How do you know that A equals 2 and B equals 1?
So our general equation for our ellipses is this yada yada stuff on top, and then it's A squared and B squared on the bottom. A is always the bigger one though. So 4 is A squared, 1 is B squared.
Okay.
All right, now our foci, who remembers the equation to find our C value?
C squared equals A squared minus.
Good, C squared equals A squared minus B squared. This is another correction I need to make for this class period. When we solve for C, we're only taking the positive value of it because C represents a distance. Can we have negative distances? No. So remember, you take square root, you've got plus. The answer is no. Did you say yes, Becca? Oh, you said yes, we could have negative distance. So, what was I saying? When we take square roots, we do have to have plus or minus, but because C represents a distance, we're using only the positive radical. But we're still adding and subtracting it, so it doesn't really change what we're doing. Okay, so our foci here, C is the square root of A squared, which is 4, minus B squared, which is 1, so square root is 3. My foci always affects the same thing my A values affect. So if my A affects my x's, my foci, my C affects my x's. So I'm just going to simply take my center there. It affects my x's. So I have -3 minus root 3. And then -3 plus root 3. Questions with that? So let's do another completing the square. Looks like we're gonna have to do a little bit of factoring here. So again, we want to get all of our x's, then all of our y's, and let's go move our constant over. So I have 9x squared plus 36x. I'm gonna leave my gap. I've got plus 4y squared plus 24y, go leave my gap, equals -36. Oh man, we've got coefficients on both. We're gonna have to factor that out on both sides. Not too big of a deal though. What can I factor out of my red? 9. I just want that GCF. I don't GCF of my coefficients. So I've got x squared plus 4x plus. Let's go and take care of our y's as well. What do I factor out of my y's? 4y squared plus 6y plus yeah. Okay. B over 2 quantity squared, what goes here in my padding for my classes? What's B over 2 quantity squared? Good. So I'm adding 4, but how much do I have to add to the other side? Good. 9 times 4, which is 36. Let's go and do this one here. b over 2 quantity squared. What would that give me? 9. Again, how much am I adding over here? Hey, I got my 36. Okay. So I've got 9 times, what do my x's factor into? X plus 2 quantity squared plus 4 times, what do my y's factor into? 3. Y plus 3 quantity squared. And what do we get all of this to simplify down to? 36. You do what you need to, like write down what you need to be able to complete your square. If you don't have to write this stuff down, you can do it eventually, that's awesome. Me personally, I sometimes have to write down a little bit of it, but it also might be helpful for you to go ahead and start writing the next step. Because once you figure out, oh, b divided by 2, that's 2, so I know it's going to be x plus 2 quantity squared. Okay, now I'll take that 2 and square it, it's 4, add that to both sides. So if you want to like kind of write a couple steps at the same time, that's fine. Okay, are we done? What must we do? Okay, I heard some mumblings and I don't think they're the same thing. Okay, divide by 36. Okay. So, 36. Oh, how nice of you, Mrs. Margraf, to give us numbers that nicely divide. You're welcome. Okay, so our equation would be x plus 2 quantity squared divided by 1. 4 plus y plus 3 quantity squared divided by equals 1. Yay! Oh my goodness, this is so satisfying to complete the square. I missed doing it. Okay, what is my a value? Remember, a is the bigger? 3. A will always be your bigger one. And so my b value is. Alright, I want you guys to go ahead and fill out your characteristics there, the center, the vertices, the co-vertices, and the foci. There's a place in Ohio called Foci. I think it's a restaurant down here. It's not a restaurant.
I know.
Oh, like fruit? I just want to lose one of those. I don't even see it. Alright, check and see what you got. Center is -2, -3. Vertices are -2, -6, -2, 0. My A's are with my Y's, so my vertices affect the Y's. Co-vertices, -4, -3, 0, -3. B is with the X's, so my X's change. My C value was square root of 5. Did you guys get square root of 5?
Yes.
Good. And my C affects the same thing as my A, so C is going to affect the Y's. So X has stayed the same. They both have -2 for X, and then -3 minus root 5, -3 plus root 5. Okay, questions with that? Awesome. All right, I want you guys to go and do these bottom 4. Work with your shoulder partner. 3, 4, 5, and 6. You're right. Number 3 is vertices and co-vertices. Yeah, it's in the bin over there, day 1. Why is it at the film when it looks like a pot? I'm gonna tell your mother you said that.
She doesn't like geometry.
Oh, that's sad. Never mind. I'll just wallow in the corner maybe. Again, feel free to talk to one another to work on these. Well, I have a lot of students. So these ones you didn't have to complete the square, you just had to think. Some of us were refusing to do. I won't name any names. Okay, so you just had to think about what the information is given to you and what's your A and B value from there. So our first one, they just simply give us our vertices and co-vertices. We know that A is the larger value and B is the smaller value. We can see that it's the same amount up and down and left and right. So our center is at 0, 0. And then we have it with 5 up and down. So that's going to be my A value. With 3 left, right, that's a smaller one, so our B value is 3. And since my A affected my Y's, and that's going to be area to my Y's, A squared. And then B affected the X's, everything else squared. Over here, they gave us our center, and they told us the length of our major and minor axes, so that allowed us to find our A value. So if the entire length is 6, then my A value would be 3. Entire length is 4, my B value is 2. Now, why do they tell me parallel to the x-axis and parallel to the y-axis? What does that tell me about it?
It is longer, more than
Okay, how do you know that? Good. So our parallel to the x-axis, that's the horizontal one, that's the major axis. So that means that our A value affects the horizontal one, so our X is there. That's how we know that. Good. All right, 5. Center at the origin. Again, they give us a vertex. We can get our A value from there. The vertex, that's our B value. Our last one here. So our center is 0, 0. Our vertex allows us to find our A value. Instead of giving us our B value, they gave us our focus. Because my center is 0, 0, I can pull that my C value is root 33. And then I just plug into C squared equals A squared minus B squared to solve for my B squared value. So B squared is 16. And again, my vertex affects the X value, so my A will read the X. Questions for that? All right, what's your homework for tonight? Paper about to what is it called?
Ellipses, day 2.
Good, ellipses day 2.
I thought, see, I
Honestly. Well, actually, it's like all there.
I need to get this.
Is there anyone that did not get the whole version? I thought I didn't count it on.
I know what the last one is.
What did I